Okay, welcome to week 5. We're going to begin talking about segmentation modeling, which is unsupervised learning. So that's different than what we had talked about over the last 3 weeks, talking about um, supervised learning, classification, modeling. So let's just kind of dive right in. A couple things. First of all, for week 5, our objectives is the first part of the CRISP DM process again. So defining your business objective, define your modeling approach, design a modeling process, think about other data that you might want to bring into this, investigate your data sources, select which ones to use, perform a basic exploration of your data, validation and cleaning, enriching your data, and providing guidance on the validation. So that covers the first 3 steps of the CRISP DM process. Now, I want to talk a little bit about the differences. So, classification looks to draw some conclusions from observed values. That's going to be a heavier focus on supervised modeling. That's where we had the bagging, the boosting, the decision trees, the shade, the software vector machine, for instance, support vector machine. Behavioral segmentation is going to be looking at divisions of the market, heterogeneous market, relatively more homogeneous segments, looking at geographic locations, demographics, etc. For example, you want to try to figure out what's going to be the way to minimize that risk of determining which products have the best chances of gaining a target market share. This is going to be clustering is what this is going to be. So really the value for doing this is it allows you to reach your particular customer segment more effectively. Now, quite often, these 2 techniques will be used in conjunction with each other, and in many cases, you'll start off with doing some behavioral segmentation and then turn around and do some classification modeling afterwards. So once you kind of understand your market, which you can do with the clustering, then you turn around and you try to predict who's going to respond back to it. So that's how these 2 pieces interact with each other. Now, your data set for this week, it's going to be a segmentation model data set. In the text, it's got references to the specific fields, but just as a general rule, there's going to be a customer identifier. That's the first field that's in there. There's going to be calls, like total number of calls and total minutes of calls going out as well. There's also some flag fields that are in there. There's 2 flag fields that are in there. But really what you're going to be looking at is either looking at like the minutes or the number of calls, the calls counts. And so that's really kind of what you see here is the data set and how it breaks down. Now, what are we going to do? For this week, again, you have to build the first part of the model. So you have to build your source node, you have to build a type, you have to do some EDA, capture that inside of an analysis document. The next things which we'll be building onto the model, so this week you'll want to just at least tag them in your model, is you'll want to build in a primary component factor analysis. That's going to basically take all the fields that you feed into it as the input and try to cluster those up into the most significant factors to look at the back and explain the majority of the variance of the data that you're looking at. We'll then feed that into an auto cluster, and the auto cluster will run a couple of models. So we're going to be focusing on k-means and the 2-step models in this particular course. Now there is a Cohenan out there, and there's some other models that were previously available. To keep this simple for this course, we're just going to look at k-means and the 2-step. So you'll see that Cohenan is an option inside of there, and by all means, feel free to experiment with it. But really, you're going to look for either a k-means or a 2-step for your final model that you'll build out of it. And then basically from that final model, you'll want to do some tuning and then produce that out into a table. So this is where we're going as part of the entire model. This initial model here, just build it up these first steps all the way through the auto cluster. That's what you need to do for week 5. Now I'll also kind of get into this a little bit deeper as we go next week into the evaluation piece of it. But some of the things which we're going to be looking at is the cluster size, the difference, the quality of the clusters, as well as the silhouette, which is a measurement of the cohesion and separation. So that's a measurement of the quality. So when you first run this, one of the first things you should look at is this, saying, is this in the good area? Or if not, then there's something that could need some additional tuning. Now you'll also want to look at the distribution of the clusters. So this one right here is telling me cluster 1 has a large number of records, almost 75% of the records, 3/4 of the records. So this is not the best. What I'm looking at here is this is not the best. Now, as I also look down here, this ratio of largest to smallest, that's another example, another measurement that tells me the quality of this model is really not very good. So while we may have good silhouette, overall cluster distribution and the ratio, those two measurements there, those are not good. So then what we'll do is we'll go through some tuning exercises. First of all, we'll look at the anomalies. We'll pull anomalies off of it, and we'll see if those anomalies should be excluded. If they should be excluded, then feeding that into your PCA factor, and then from your PCA factor, rerunning your auto cluster. So this will be something we'll get into next week of looking at the anomalies. And then finally, a more tuned look at a cluster. So if we're looking here, we can say down here in this k-means, for instance, we can see this k-means has a much more uniform distribution of the cluster. So I'm looking at the cluster size right here. Cluster sizes relatively, so not completely equal, but relatively equal across those clusters. This is a much better model. We're also seeing the silhouette is still good, and we see the ratio size of largest to smallest clusters is low. So this is starting to look like a much better, much more tuned model. So this would be an ideal state. This would be one that is of still poor quality, but it's something that you would start to work with. First run, you're going to have something that probably looks like this. As you tune it, continue to work with it, it'll look something that looks like this. So again, building these out, start with that source model in an Excel file. And here I'm just using that segmentation model. Now I will also provide you a smaller version of that segmentation model that you can use too as well as the slides with this presentation. From that, I'll perform my EDA. So I'll go ahead and run that into an audit node. And right here, then make observations about what I'm seeing. So you can see some distributions. You can see how it's tailed to the left-hand side, for instance. Those would all be things that I'd want to capture. Max and min values, median, mean, standard deviation, skewedness, etc. We can see that it has valid, so you can go into the quality again, and it looks like these all have valid records too as well. All things that you'd want to call out inside of your EDA. Now when we get to the anomaly node, from the anomaly node, it's having 3 different peer groups that it's separating as part of this. And within those peer groups, it's going to look for those that could potentially be anomalies. Now what I can do then is just do a simple select, and from that select where anomaly equals true. So this is identified as a potential anomaly. It may not actually be one. So then what you'll want to do is you want to look at the table, look at these records. Now here we see that there's 20 records that fall into that category, and you decide, does this make sense? Yes or no? Are these really anomalies? If they are anomalies, then what you can do is you can select those out by saying keep it where the anomaly equals false, and then only the records which the anomaly node are not filtering out, that will filter out into your PCA factor. Now within PCA factor, I'd want to set that, I would want to use expert mode, and then down here in the rotation, I'd want to change that to Varimax. Varimax is going to make it easier to interpret, and so that's, again, an aspect of this that I want to set up. It's going to make it easier for you when you're reading the results that come out of it. Now I would also kind of set this to hide the values that are below 0.3, for instance. I only want to look at the most critical of the factors that's coming out of it. Now when I run this, it's going to take a minute. What this is going to do is this is going to set up this is going to set up 3 or 4 factors as part of that. And it'll look at all of the fields that you're feeding into it and then make combinations of those fields. So right here we can kind of see there's going to be 4 factors that it produces. And the first factor, for instance, is going to be a percentage of these combined together. From the PCA factor, I'd want to put another type node here at this point. So coming in, this first type node here, it's feeding in all the values that I want to consider. But now this one here, if we're going to use PCA factor, then you'd want to filter it down to just the factors. And those are the ones that you want to actually use on the cluster coming out of the back end of it. Run it into an auto cluster. Running it into an auto cluster, we see looking at the k-means and the two-step. The two-step looks a little bit better than the k-means. And again, we can look at the number of clusters, the silhouette that goes along with it. And then I'm going to break off and build an actual two-step on the side. This gets back into that same visualization which I showed earlier on the slide set. Now here we can see that there's 4 clusters. It's good that there's more than at least 3. More than 3 is better, but not like 30 clusters. That's probably not a good quality cluster at that point. Right here I'm seeing 4 clusters of relatively decent size, a ratio of that's relatively small. I'm also seeing a cluster silhouette that is in the good at this point too as well. So this is, again, relatively good tuned. And then I'm just going to dump it off in a distribution curve right here, distribution plot, and I can see the 4 clusters right here. And so, again, for this week, for week 5, you'll take it up to the auto cluster stage of it. Going back to this picture. You'll take it up to the auto cluster stage right here. So have a PCA factor, have an auto cluster, produce the auto cluster, and then write it up in your analysis document what's going on with the values. For the next week, week 6, you're going to add on the anomaly detection. You'll add on the anomaly detection, refine your PCA factor, produce the cluster, build out a separate node, k-means or two-step, depending on what you use in your type node as the sources from it, and then continue to tune, ideally looking for a tuning something along the range of this. So that's really what we're going to work on. If you have any questions, got office hours on Wednesday at 7 p.m. Also available email or in the help desk. Just please reach out if you have any questions. Have a good week. Thanks.